You might have already seen this or similar question. It looks simple, but there's a lot of depth into that question. I'll be talking about different levels of depth in that question, and just like the name of the channel, we will not just be providing a normal answer, we will be extracting learnings from it and be going beyond answers. Enough branding and music, let's come to the content. We will start with interpretation of the question. What is given to us is that there is a solution which consists of ethanol and water. So we can say solution is equal to ethanol plus water, whatever the amount may be. Now the next data that is given in the question is about the mole fraction of ethanol, and we know the definition of mole fraction, that mole fraction of a component of the solution is equal to number of moles of the component upon total number of moles of solution. And we use this formula for ethanol to get that the mole fraction of ethanol is equal to number of moles of ethanol upon number of moles of solution, which is given to be 0.04. Alright, now we write this in a better notation. We use M to denote number of moles and the subscript E to denote ethanol. So we have number of moles of ethanol upon number of moles of solution. What is the content of a solution? Water plus ethanol. So we say number of moles of ethanol plus number of moles of water. This must be equal to 0.04. Alright, now what can we do next is we can say mole fraction of water must be equal to 0.96. We can get this in two ways. Firstly, by observation, we know the solution consists of only ethanol and water, so the mole fraction of water will be 1 minus mole fraction of ethanol, which equals to 0.96, and we can get this by mathematics as well. So let's call this to be equation 1, and we multiply the equation 1 by negative 1, so we will get something like this. Alright, and now we add plus 1 on both sides, so plus 1, and we get the same result, that the molar fraction of water is equal to 0.96, and we call this equation second. We consider equation 1 and equation 2. Both of them have the same denominator, and that is why we can, yes, adding them will give us 1, but apart from that, if we divide these two equations, we will get the ratio of number of moles of ethanol to number of moles of water. Let's do it. Let me explain it in here. It's just dividing 0.04 upon 0.96, which gives 1 upon 24. So what does this mean? Through this equation or through this proportion, we don't know the value of number of moles of ethanol or water. We don't know that. All we know is their relative amounts. So if I say, if number of moles of ethanol are say X, then this must imply that number of moles of water should be 24 times X. This is what we can state with confidence. And now we don't have to find out X, and I'm not talking about real life here. In equation we don't have to find out X, because we have to find out concentration in terms of molarity, which is equal to number of moles upon volume of solution in liter. Let's see this. The concentration of ethanol will be equal to number of moles of ethanol, which we have assumed to be X upon volume of solution, which is volume of ethanol plus water. Now we have X because it's in mole, so since it's number of moles we don't write the unit, right? And we have volume of ethanol, volume of X mole of ethanol plus volume of 24x mole of H2O. This is what we get. Now we can factor out this X from both numerator and denominator, and we'll get this is in fact molarity is in fact equal to 1 upon volume of, so this is equal to 1 upon volume of 1 mole ethanol plus 24 mole water. And this is the end of our basic interpretation of the question. And now we will use the first method or the first approach to solve this question, which is approximating dilutions.